This is just a short little video about emergence and the process thereof. We're going to use Langton's ant as a discussion of emergence. In this case, we have an arrow instead of an ant because that tells you what direction the ant would be looking in. I know you can't see it, but this is actually a grid, and it is currently all white. And if I went forward on this a little bit, you can see that there are blocks and they're all the same size. So there you go, that's your grid universe that this ant is living in. And it's currently pointed up at this point. Oh, and as I showed, I can go forward and back and forward and back. And the ant does two things, and we can discover this by just running through it. If it's on a white square, it rotates counterclockwise and turns the square it had been on black, stepping forward. If it gets to a black square, well, it rotates the other way, turns the thing back to white, and keeps going. That's it. That's all it does. Not very interesting, and not particularly complex. On top of that, if you run it forward, just like this, you see sort of maybe little patterns going, sort of looking like a circle at the moment. You let it run a little bit longer, and it starts to build this sort of X-shaped thing. There it is coming in now. But yeah, it's not really doing much now, is it? I mean, it's making a bit of a mess inside, doesn't seem to be doing anything at all. And now it's building outside of that, and it's even less of a pattern. I mean, if you can see anything in that, congratulations, you can find bunnies in clouds. It doesn't look any more significant than that. Now this is fairly slow. I can go through and make this a lot faster and just go wee, and look at that. It's still nothing. It's a mess. It's a chaotic, unordered, just mess of junk happening. There is nothing significant going on. And you can see you can go for a very long time and nothing's happening. You're just getting more and more and more of the same mess that you got all of this time up to this point. But then what would you expect from something so simple? So you shouldn't really expect anything to change. It should just be a mess forever. And that's really what you see right up until, oh, yeah, there. Okay. So this stuff right around here, this path, that is not a mess. That is order. That is something that has come out of this gigantic mess of nothing, really. You can see this pattern here, which sort of locks in, has something of a precursor here. Maybe you could argue that this is a little bit of a precursor here, although it's out of place and not as complete and has extra bits onto it. But there's just nothing there to really suggest it would come to this. Now, this thing's been around for a while, so you'd think that scientists or mathematicians would be able to say, okay, well, we understand how this comes about. We'd be able to describe in mathematical or scientific terms how you get from all the way back at this, all the way out to here. No. The only way to describe this is to start at the beginning and list all of the direction changes you made, and that's how you get out here. So, emergent things are not predictable. You can't state in advance what they're going to do. You know all the rules. You know exactly what the behavior is. The behavior hasn't changed. I mean, we're on a black square now, and lo and behold, it rotates clockwise and takes a step forward, changing the thing that it was on. Now it's on a white square, it'll rotate counterclockwise. Look at that. It's doing exactly the same thing. Nothing's changed. It's just our perception of it that's changed, and there being a pattern that has locked in. You get this sort of thing in physical systems all the time. You have things that behave the way they behave because they are what they are, and doing so leads them to behavior that you wouldn't expect, cannot predict, and can't really reduce to anything simpler in order to understand it, which is what understanding is. It means to take something complex and reduce it to something you can comprehend. Um, this sort of thing could be the origins of things like life on Earth. Um, Certainly, if you had a whole bunch of chemistry doing this for most of the time that it was around, and then you had a little bit of this and a little bit of this, and then suddenly it locks into a pattern, and you have the start of life. Do we know that that happened? No, of course not. We have bits and pieces, but that look like they might be this and might be this, but we don't have the full thing. We don't have the full setup yet. And to be fair, we may not for a very long time, if ever, because there's going to potentially be a lot of steps in that. And you've got all sorts of other things in which emergent processes may simply do this sort of thing. The advent of intelligence, the advent of anthropology, the advent of stellar formation, all of these things could be okay. You have a whole bunch of stuff acting in a very chaotic, unordered mess of a manner. They're doing what they do, they don't do anything different, and then suddenly that locks into a pattern on you. Um, all we can really do is sort of observe the before mess and the after, and then see if we can try and figure out where this formation thing occurs. But it certainly is a good explanation of how some things can come into existence from seemingly nothingness and seeming disorder and seeming randomness, when they're not random, really. I mean, there's no random numbers in this. If I run this forward and back, it's the same thing. This isn't a movie, really. I have a little computer program generating this stuff and running through all of this, to generate it. That's why I can run it back and forth. But that's all there is. It's just this sort of thing over and over and over again, and this will continue indefinitely until it runs into something else like itself, and then it just makes a mess again. Um, but yeah, it's just a physical system, and there's nothing particularly special about it.